piece of code, or
It can be, but
works the way it does?
it can be, but a lot of people also do think it can be harder to read though. It does have a little more complexity of readability usually, because you have to understand how the self-referential system works and how it would be the edge case and what causes the rollback up the chain goes on.
Yeah.
Because again, just to kind of clarify a little bit, not that button, that right here. And just to bring up the concept of the one I mentioned earlier.
Sorry.
You got that away. Chat out of the way. Oh wait, I think I saw a chat pop up that I didn't read. What was that? Searching askew still work. Oh, I think it does. Yeah. Yeah, it totally still does. So there's a lot of like you can't see it. So yeah, if you guys Google search askew.
What the heck?
I think Christian just Google searched askew. So,
Oh, that's wild.
yep. So you got askew. You got anyone ever play Star Fox
Well, that's pretty
when they
cool.
were a kid?
Yeah, Super Nintendo.
Yeah, do a
Oh,
barrel
dude,
roll.
barrel roll still works.
Yep. No, they're not getting rid of that.
Oh, that's awesome.
Anyone did StarCraft? You got Zerg Rush.
Oh, Zerg Rush. Yeah, I forgot all this. This is why you should be
Trigger
doing school
automatic.
instead of
Do
actually
a barrel
doing
roll.
school.
Does that not trigger automatically anymore? Aw.
Oh, I
But we're
guess so.
looking at a form that says conflict checked. Are you showing us or?
What's that?
So we're looking at a form. I don't know if you're showing what you were doing.
Ah, dang it.
Because Zerg Rush has its own webpage.
Yeah, it was.
I was a little confused there.
I did askew. See that one work? Do a barrel roll.
Do a barrel roll. Yeah.
Flips the screen. Oh wait. Snap. Does it work still?
Yeah,
Does it?
this is wild. There's a whole website for Google Easter eggs.
Doesn't it like disappear though?
It was, but there was a way to trigger it. I feel like you had to like click on the Infinity Stone, like the gauntlet or something. Ah, dang it.
Yeah. Oh, Thanos gauntlet.
Low.
No, it says just a search Thanos snap, and then there
It was,
should have been
right?
like a font that appeared. I don't know.
Yeah,
Capital
they may have
T
disabled
and
it.
capital
That's
S.
possible. Really?
Oh, I disabled it. Looks like
There's
it.
a trick on the after it.
What? I don't know.
What do you have to do?
What?
I don't know, it was when you said Thanos snap, it said trick at the end as a suggestion.
Well, yeah, because that was, yeah.
Oh, you
Yes,
gotta click that.
this is where it was. Yeah, you had, this was,
Right
when
there,
you
yeah.
saw this,
It-
you
it-
clicked
yeah.
on that, it would trigger it. Yep. And then random results would start to
Didn't
disappear.
work.
Nope, hold on. There it goes.
Oh, there it goes. Nice.
Are you muted? No, I
Yeah, I'm sharing now.
Oh wow, that's pretty crazy.
Yeah, it was a really good one. I actually liked that one a lot. That was fun to see. But
I think the best.
oh
thing-
look, and the results actually get cut in half. The last, after it removes a couple from the screen, it actually takes the results here and actually cuts them in half. So yeah, no, there's a ton of secret Easter eggs you can find in the Google system. I'm surprised they got. Yeah, it's weird that they got rid of that Easter egg on the side there now. That sidebar didn't show up. Weird. Anyway, there's a bunch of those, but let's go back to what I was showing you now. So the one thing I want to bring up again, last thing I want to bring up, now that we had a little bit of fun, was again, just to reiterate again, the complexity that comes with recursion and why, again, you want to be careful of it. So I mentioned factorial. So factorial is the idea of doing 5 factorial, which is the exclamation point. So 5 factorial, to get a factorial number, you do 1 to that number multiplying each time. So you do 1 times 2 times 3 times 4 times 5. And I was just doing the dots because I don't like my x's, but we'll do the x's. Screw it. So that's how you get factorial of 5. You do 5 times 4 times 3 times 2 times 1. So technically, if you wanted to say it though, the factorial of 5 is 5 times the factorial of 4, right? So in that case, we're going to say, well, that means, okay, well, then to get the factorial of 4, we can just do 4 times the factorial of 3, right?
Mhm.
And again, to get the factorial of 3, we do 3 times the factorial of 2. To get the factorial of 2, we do 2 times the factorial of 1. Well, what's the factorial of 1?
1.
One.
Right. And that's our base case. We now have our base case. Our base case is the factorial of 1. So as soon as we do factorial of 1, we know we can just return 1. 2 times 1 is
2.
So that's our return there. So now it rolls back. So now we got 3 times 2 is
6.
thank you. So that rolls up back the chain up here. So there's our 6. 6 times 4 is
24.
24. So that rolls back up the chain. And 5 times 24 is
100 and 110.
96. You said 5 times? Oh no, 120. Oh, I was thinking 5 times 4.
120, yeah.
yep, 120.
Hmm.
And so that's our factorial of 5. And so you could very easily say that a factorial of n is n times n minus 1 factorial. And that's a recursive function. But again, that becomes very repetitive. You saw how many of these breakdowns we had to have, right?
Yep.
In order to get that up. And so that's how much memory I'm taking in my whiteboard to figure out the same thing when I could have just done it here. When over here, I could just do 5 times 4, 20 times 3, 60 times 2, 120. And now look how much smaller my box is.
Isn't the time complexity of that O of n factorial, basically,
I believe so.
which is really exponential.
Mhm. And again, really the difference in processing on these two is minimal. What you're really getting out of these two doing the recursive versus just the for loop is going to be your memory storage. Because again, we're storing each time a copy of the function each and every time as we do that. So in factorial of 5, that doesn't seem like a lot. But to do factorial 20, we're creating 20 copies of a function. So you have a function call, function call, function call, function call, and I have to write 20 boxes to store that checkpoint each and every time, because each one is going to say, hey, it's pretty much, imagine a telephone chain, or you're asking a question and you're trying to get the question answered by someone, and you add, like, I'm going to say, hey, Elaine, what's the stock price of Facebook? And Elaine's like, I have no idea. And so then she has, I'll ask Jim, he knows stuff. Jim, what's the stock price of Facebook? Jim's like, I don't know. Hey, David, what's the stock price of Facebook? He's like, I don't know. Jeremy, do you know the stock price of Facebook? And all this time, I'm still waiting. Elaine's now waiting. Jim's now waiting. Jeremy goes to Richie. Richie goes to Joelle. Joelle goes to Alita. Alita goes to Emilio. Emilio goes to Cullen. Cullen goes to Christian. Christian goes to Evan, and so on until Evan starts replying back. Now, of course, Evan's going to reply back to who he got asked. So he's going to reply back to Cullen, who replies back to Christian, who replies back to Emilio, who replies back to Christian, and replies back to Alita, to Joel, to Richie, Jeremy, David, Jim, Elaine, and then finally I get the response that I wanted. And this is where things can get a little crazy, and that's where recursion, you want to make sure you're doing the right thing. And so just doing this simple thing doesn't really make sense for recursion. Are we kind of understanding what I'm talking about? You see where recursion can take up a lot of memory and a lot of resources. You can consider me a copy of the function waiting in memory for Elaine to call hers, and Elaine's now sitting in memory waiting for Jim, David, and then all down that chain. As everyone's waiting for their response from their respective person, they're just taking up memory in the computer. Now, everything I did took a lot faster, but imagine something a little bit more complex and how much time that memory can be used.
I understand that this wouldn't be the problem because we just do multiplication, but can't recursion go a little bit crazy if one of your calculations have to go like out of bounds or going some insane direction and while it's doing it?
Very much so. Yeah, you definitely have to make sure you're taking into consideration what each instance of the call is doing and what its purpose is. I will find some more examples of where recursion makes sense so that you guys can play with it a bit more and make sure you have a good understanding, strong understanding of recursion because it is a very powerful tool and it's very useful. If understood correctly and used correctly. So I'll make sure to find a couple more examples as we go. But for now, let's
think,
look.
Cliff, I
ahead.
think it asks the time complexity of the recursion we're doing, and I would think it's linear, not exponential.
Yeah, no, time complexity is not where you're hitting on this. So on that one, the time complexity wasn't the issue. It would be the space complexity.
Okay.
Yeah, recursion has a space issue, not really a time issue.
Like a memory leak type of thing.
Yep. It takes a lot. It takes way more memory to do a recursive call than to do a for loop. Because each copy is, you're not just copying, you're not just keeping track of variables, you're keeping track of each variable in each function call. So you're creating copies the whole way through. So in the for loop of factorial, if I bring that whiteboard back up again, you had to think about it. That wrong button, I won't do that. Nope, go away. Do that, So factorialize on a for loop, we would have the number n, which is what we want, and that's factorial because we're trying to find the result of n pound. So in our for loop, we would just do for x equals n, x greater than or equal to 1, then x plus plus. I'll keep this to mostly pseudocode. And then we just do our sum or result, if you want to call it, equal to 0. We say n is equal to 5, comma. And so we can do sum equals, we should probably set that to 1 actually, just to be on the safe side. Not 0, because anything times 0 is 0.
Yep.
That. And then we'll do sum equals sum. Dang it. Times x. This up a little bit, make this look a little nicer. X. Or we should change that to y or something. Anyway, so sum is equal to sum times x. And then that's it. Return sum. So what happens here is that as we go through, x starts at 5. 1 times 5 is 5, right? So we see we do 5. So then our sum becomes 5. We then iterate. X is now 4. 5 times 4 is our 20. This gets, oh, I did plus plus, didn't I? I want to do minus minus. No one caught me on that. Minus minus. So then our 4 becomes 3. 3 times 20. We know that becomes 60. Again, we decrease. We're down to 2. 2 times 60 is 120. And then we hit the 1, which is our base case, which we still technically do. I could actually say, well, it's greater than 1 because anything times 1 is there. So we can just do that because our sum is already was equal to 1. So we just do that. And that way, when we hit 1 on x, we're done. We don't do anything. We return the 120. Now in recursion, what ends up happening, our recursion function is going to look like this. Let me make this a little bigger. I don't know what that looked like for you guys, but our recursion call is going to be, what is it? We got recursion of n, so REC n is equal to if n equals 1, turn 1 equal. Parentheses, please. Thank you. So if our n is equal to 1, we return. We're done. Otherwise, else, we return, which again, we don't really need the else because we're doing a return, so I'm actually going to get rid of that. I don't need that. Oh, not there. And otherwise, REC, return, n times REC, times again, let's get that in there better, n minus 1. And so that's what this looks like. We have recursion n. If n is equal to 1, return 1. Otherwise, return n times recursion n1. And so in the first loop through, we have our n is equal to 5. And so we hit this, though, if n is equal to 1, which it isn't, we're going to skip down here. I'm going to do 5 times rec 5 minus 1. So that means we then have this function right here is now stuck here. We call recursion, we create a new recursion, recursion 4. So we have REC, do this a little different, sure makes sense. REC 5. We have REC 4, so again, if 4 is equal to 1, return 1, otherwise return 4 times REC 4 minus 1. And so now we see we have this block of the code, which is the 5. We have this block of code, which is the 4. So we have to do it again because we're not equal to this. We hit this line again. And so now we have REC 3. If 3 equal 1, return 1. Otherwise return 3 times REC 3 minus 1. Are we starting to see the kind of the repetition here? And I'm specifically writing out each function because I want to make sure it's understood that we're running another instance of the exact same method, and that other method is still in memory. That a copy of each method is being stored in memory, waiting for the next call to finish. So it's calling the method again, initializing a new n, and running through the same code each and every time. And so that means we're going to do it again. REC2. If 2 equals 1, return 1, else return 2 times REC 2 minus 1. So we have 4 versions of the method running now. And then lastly, then we finally have REC1. If 1 equals 1, turn 1. And now we can stop there because now we actually hit this. So we're not going to go through the whole method. We stop here, return, we hit back to red. So this now returns the 1. What technically happens is that this code, we do this quick. This code right here is going to get replaced with that number, number 1. And then we can finish up this code. So this is going to finish, return 2 times 1 for 2, which means, let's do this, switch my color to red. Love it. This is getting replaced now by the result. Now we have the result. So now we can replace that with the result 2. That gets returned up to the next one. So change color again, to green. So this now has a result. So this gets replaced with our 6. Our 4 times 6. So that's going to return back up. And so that means we now have, what's the purple there? This is now good to replace. So that gets replaced. The result 6 times 4, which was that again? 24, right?
24.
Yeah.
Yep.
And then that gets returned up for our 120. And so what I want you guys to see again is this idea of like, these were the variables we used here, and I was able to fit it all within that area. And yet for recursion, for this function, all of this was created in memory. Do we see that variation now? Do we see why in this example in factorial, even though yes, we can do recursion, it doesn't make sense to do it with recursion. We can use a much simpler function and just use the variables as is. We don't need to save the state of each of those ends. We don't need to do more. Does that make sense?
Yep.
So what I want to do, like I said, what I'm going to do next time is on Thursday, I'm going to give you an example, another example where recursion makes sense and it's necessary. So you can get some a little more practice on it. And we'll be able to review those a little more. Let's do that now with the current problem we just had.
This is just doing the factorial is just it's a very basic recursion just to show how it actually
It's a great way to see how recursion works and understand what a base case is, but
Yeah.
I would never ever actually use recursion to solve it. So that's the main
Yeah.
reason why I wanted to bring that up. and help to make sure it makes sense. I see chat that I'm not noticing. Christian said BRB, but he's already back. Jeremy said BRB at 8:02. It is 8:03, so yeah, he's probably still away. All right. All right, so let's pull up function. Where was it? Where'd you go, Slack? There you are. Okay. So that one was going to be the recursive digit sum. Yep, that was it. All right, so we define this. So what we're looking for is we define a superdigit of an integer x based on the following rules. Given an integer, we need to find the superdigit of the integer. If x has only one digit, then its superdigit is x. Otherwise, the superdigit of x is equal to the superdigit of the sum of all the digits of x. For example, the superdigit of 9875 is calculated as 29. So 9 plus 8 plus 10 plus 5 is 29. Superdigit 29 is 2 plus 9. 11 is 1 plus 1, and 2, 2. Make sense?
Yep.
See what we're doing here? We're adding all the digits together, and if our digit is not a single number, we can do it again until we have a single number. So pretty much as long as our number is greater than 9, we need to keep doing it. So that's a good thing to keep in mind. Like, okay, well, I just need to make sure it's one thing on it. So I could argue that's my kind of my base case, right? I'm looking for a number that is less than 10. If it's less than 10, I'm happy, but of course greater than 0. But there's no chance for us to hit that. We don't have to worry about negative numbers in this. So as long as my number is greater than 9, I need to run the superdigit again. And so if you ask me, there's two things happening here. One, we need to figure out how do we pull apart a number and add all the digits together. We need to figure out how to do this specifically, and that way we can, and then the conditional is really all the recursive thing is. Really, the recursion is not this part, really. Maybe, it might be, but for the most part, I know the recursion is just, I'm going to keep running a function, a method that's going to sum all the numbers, all the digits together, and then my recursion is going to decide, do I need to do this again or not? Or do I have the number I want? And I don't know how many times I'm going to do it, so a loop doesn't really, I could possibly do it in a while loop, but not really necessary. But again, recursion is probably the way I want to go for this, just to make my code a little simpler for myself. Otherwise, I'm just going to do a while true loop. But let's do this. So, looking at this, first thing we need to figure out is how do we pull apart a number so we can add things together, add the digits together. So I have the number. Go back to the example they gave us. The first one is the 9875. I guess the question, of course, we need to find out: are they giving us an actual number or are they giving us a string? Do we know?
String.
Oh, really?
Yeah.
They made that way too easy for you guys. Aw. That made it easy. It's more challenging to have to deal with a number, but luckily for you, I was actually going to say though, but since you guys are using Java, it actually wasn't that difficult. By taking advantage of integer division and modulo, you can easily pop off each number and do it one by one. But I guess we'll just use the string because then we can just iterate through the string. But I need to do that with an array, don't I? I gotta know how to do that in Java now. Something I forgot how to do again.
Char array.
What?
Yeah, I think I was doing a char array, and then we do parse int, right?
Yeah, I
Java
did.
has a parse int.
I did a split like a JavaScript and split it into an array.
Yeah. And you just use the char array and then parse int.
I use
You could do dot split also.
Split?
Yeah.
What did you do, Joel?
I did 2 char array.
Char array. So you did what Evan did.
Mhm.
So let's see. So on a char, can I do a parse int on a char? Good. I think we're gonna use the char array because I think it might be faster for us. Now, does char array give us an array or a list?
An array.
Okay, that was nice in unison. Cool. All right. So
Great minds think alike.
I like it. That's what I want to hear.
There's no
Uh,
char list method, unfortunately.
Equals what is it? Char array, right?
2
Two
char.
char array.
What is it? 2 char array. That was it.
Yep.
I could probably open this up in Java just to remember the items, but I think that'll work fine for now. So do that. And honestly, if this is one of those moments where it's like, you know, I'm not sure if this worked. I'm just going to do this.
Yep, I do that all the time too.
Oh, well, I'm using an array, so I can actually do this. I can actually use that syntax. I don't have to do the dot get or anything like that. Feel free to do systems out if you're like, I think this is right. Don't just assume you're right. Go ahead and test it. Don't be afraid to do that, especially in your interviews and stuff. Hit the run code and you'll see right down here. What did I forget? Oh, return statement, right?
Yeah, return 0.
That. And right here, you see your debug output is where all your system outs go. So right here is where you can see what I outputted from my debugging. Because again, we do know that somewhere in here, there's probably a system out or a write or a read or something in here, which is what the standard out got and what hacker rank got. This is what your console out is. It's what you're putting out to the console that you wanted to put in for debugging and for testing. So they do keep it separate for you, which is nice. I do like that. It actually used to not be like that. Well, like when I first started HackerRank, they didn't have that separation. They just said your outputs and it was included in the output. So I do like that they separated it now. Anyway, so yeah, don't be afraid to do these to make sure that the line you wrote makes sense. So we split it up. So all we need now is a way to combine the numbers. What do I want to do? For me, I think I might want to make that a separate function that I can call instead of having to put the logic in this, because superdigit really isn't meant to add the numbers together. It's just to determine if n is a superdigit, right?
Mm-hmm.
Is this a superdigit? What is k?
It's how many times you have to multiply.
No, that's how it creates the super digit. So for example, if it gives you a 4, 5, 6,
You
right?
can concatenate
And K
that
would be
many
3
times.
times. It makes you.
Oh, right. We've
add
got
a
it.
string.
I forgot about that. Yeah, you got to create the string that many extra times. Right. That's annoying. Is there a way to duplicate an array in Java?
Well, you wouldn't have to duplicate it because if you get the sum of
Oh,
digits,
right.
then you would just multiply by k.
You're right. That makes sense. Good point. Good call on that. Yeah, that's a good point. Yeah, I completely forgot about that. If our string is 987 and they had a k of 2, that'd be 987, 987, which again is just this plus this. You just put parentheses around the 2. So yeah, that makes sense. Oh yeah, good call. Much easier. Awesome. Okay.
That's what I'm here for.
Yep. And that's where those moments right there, when you can make those realizations, help you to reduce the brute force. There was a quick second for there that I was thinking like, oh, I got to actually make that array. Good catch, realizing you don't actually have to make that item. So good catch. So all we need to do now is we just want to get the total of our digits. So I'm going to make a function that's going to do that for ourselves. I don't want to have to put that logic in superdigit. Superdigit should not be adding the numbers up. Superdigit should just be deciding is what we have a superdigit. So I'm going to do simply array.
You gotta make a static in front of that.
I will. Yeah, you're right. Not gonna be public. Yeah, public. It's private. Make it private because this is calling it. So this class is the solution class doesn't need access to it.
And a return, right? You gotta need to
And
return that.
we're gonna return it. Yep, return it. And one thing I'll say, like, I'm perfectly fine not putting the return type until I know what I'm returning.
Oh,
So I sometimes will leave the return type out. Sometimes you'll notice me do that, and I'll put the return type in later. But good catch. No, it's good to actually have it in the early. It can be nice to have it. And then
that's a good
I
idea.
do put
though,
it.
too, 'cause you'll-
Yeah, but if I do put the return type right away, I always want to make sure I validate the return type immediately so that I'm covering myself. What I'm going to do next, I'm going to create our sum our sum variable to keep track of the running total. We're going to do, we actually want to touch each and every digit inside of our digits array. There's no reason, we're never going to skip any, right?
Mm-hmm.
So we're going to touch each and every one. So what should I use for this?
For each.
For
Thank you.
For each, yeah.
Yep, for each, or also known as the for in.
Yeah.
So we'll do it for, make sure again, we're going to use the looping structure, not the method. So for our digit and digits, sum plus equal, and then what's the parse int? How do we do parse int in Java?
Integer dot parse int.
integer. Why did that look wrong?
Because you change
I-
the I
It's
to
an
an
E,
H.
not an I.
In Tiger.
In Tiger. Dot
Parsing.
parse int
And then you have to put
digit.
don't you
Right.
don't you have to do string dot value of digit?
Can anyone confirm? I can try it. Console, not console.
It's expecting
Yeah, because you're using, yeah,
it's expecting a string and we're passing in a char.
All right. Well, let's give it a shot and see what we get. If that works, then I'm fine. Let's see. We'll do the run. We'll do a system.println instead of assuming this is working and writing the rest of our code. Let's make sure this works, because I probably would have just put the word digit in there and I would have then did the system out too. So either way, whether I got this from you or not, I would have still did this line anyway, just to make sure that this guy works.
Line
I
28.
never want to assume. What's that?
I think line 28 is gonna bomb. I just got a feeling. I got a feeling.
That's the exact code I wrote and it passed. So
We'll find out. I'm game to find out if it does. Yeah, but also, oh, I didn't run the method. I didn't call it. Calculate digits. Digits. Also, actually run the method. There we go. So our bug output is 13.
and then we could try. Could we run it
28.
without the string of to see what it does? Would it accept it as a char?
Yeah, definitely. So yeah, so that worked. So you can see that worked. Let's go ahead and see if we don't need that. Let's see if it'll accept the char. There's an over, and then we would be looking for an overload there. See if they had a char overload for that. No, they don't. You're right. They don't have an overload for that. Yeah, they only have the string. They don't have a char overload. That's actually kind of surprising. I think they would. Oh, whatever. Yeah. Cancel. Don't hit Command S. And make sure it still works. We'll check. Yeah, we got our 13. Good. So once we have that, okay, want to do the times k here so we can do it, is less than 10. We are good to go. We can return.
You mean less than, not greater than?
Oh, I should probably capture that. Oh, yeah, less than 2, by the way. I should probably save this. This. So less than 10, return total. Yeah, less than 10, right? Yep, good. Otherwise, we will return super digit total 1. See how that works? And the only trick here, of course, is that I'm sending it an int. What is it expecting?
It wants a string.
How do I, in Java, how do I convert an integer to a string?
.toString.
Good, good. So the idea here is that our base case is right here. This is our base case. Once we have a total from our calculate digits that is less than 10, we have a single digit. We can return that digit now.
Wait a minute, why are you returning a string again? Because that function's an int.
I'm returning a
Because
string.
string.
What's that?
It's public static int, not public static string.
Right. I'm not returning a string anywhere. I'm sending a string here.
Oh,
I'm
okay.
passing a string. Yeah, I'm passing a string to
Sorry about
this
that.
method. To this method right here. So I'm passing a string to superdigit. Superdigit returns an int. So the result of this will be an int, which then clarifies this. So this is where the recursion happens. That makes sense?
Yeah, I'm curious if that
Okay.
is that toString gonna pass it though?
It should, again, that's what we're going to check now and find out if this is gonna, so this should convert total, which is an int, to a string, which is what this wants. Again, I'm calling super digit. I'm not calling calculate digits. Calculate digits does want a char array. Super digit wants a string. And so I'm sending it that. Let's
You
see.
forgot to add the colon on line 37, semicolon.
Yep, it just yelled at me. Thank you.
Yeah, so you have to do string dot
String,
value
yeah.
up.
I was
Yeah.
gonna say, yeah, we're using a primitive type, aren't we? We're using a primitive, so there's no methods on it.
Yeah, that's why I was so
Good
I was
catch,
so-
Joel.
Yeah, I think I used a string to value of to turn it back to a string again.
That would work too. Yep, that would do it because we did that here. Yep. So string dot to value. Oh, sorry.
Not to value, just value.
Value.
Oh, but would that give it a string though? Yeah, that should give us a string, right?
Yeah,
Yeah, it brings it back to a
fine with
string
me.
again.
You're right. Good, good. Value of total. Let's try that. What did I got a 0. Why did I get 0? Hold on. We'll do a
You
couple
still have
things and
returned
find
zero
out.
there.
Yeah,
You didn't return
oh,
some.
You,
You
yeah,
did return some in your calculation digit one up there.
you're
oh,
returning
God
zero.
dang it. Good catch, good catch. Good catch. So you guys are doing good. I'm catching you. I'm giving you guys good challenges. There you go.
Oh,
Submit it. Oh
I got a
no.
couple of test
Oh,
cases wrong. Oh
yeah.
no, what happened?
I think I know what happened.
You have to return. I mean,
How
your
long?
in has to be a long, yeah.
I think I
Hey,
remember Alita mentioning that. Yeah, that what was our container, our possibilities, because like
There was a hint
the
up
times
there.
3, this thing, the times X.
Yeah,
So-
but there's a hint up there also.
25 should be a long.
Yeah, this thing. Where was it? Yeah, I remember that too.
They keep going up
Forgot,
right,
right here.
The hint right there.
Right here, this thing's crazy. And where's the
Yeah.
hint?
There's a hint up in here. They have a hint over here. It'll tell you the hint that there's a long
here,
in
crazy
this
thing
thing
there,
because
but
I'm
yeah.
remembering it.
What
I
is
remember
another
saying it was a
integer?
long.
Yeah. What's another integer data type we can store? Store integers in.
Long.
Long.
We can do long. There's also long, which is also another one too. So, and we're gonna say we're gonna return long now.
Actually, it's gonna be an int because it's gonna be one single number, so it will be an int.
Oh yeah, you're right. I think that should be fine. It's just this one that might become a long because the times k.
Yeah.
I
Yep.
think.
Yeah.
So this is the one we have to turn into a long.
But you might have to cast it though.
Yeah,
Yeah,
possible.
Possible
can't
loss
go
in
one to
conversion,
int,
yep.
You gotta cast it.
So,
Really have to cast it?
just to give it a heads up that we understand that there's a potential loss of data. Because when you're converting from a large number to a low number, the binary rollover. So this is one of the downsides of actually doing the remote sessions because I can't really share videos. I don't think you guys can hear the audio from my computer.
I didn't cast it in mine though, which is weird.
There's a way with Zoom to play audio from your computer.
There you go.
Yeah. Well, that still works, but let's see if the test cases that failed.
Ah,
Cliff, there
What's
is a
that?
way to play audio from your computer when you play
Really?
video.
Yeah.
Yep.
All right, we can do that in a second. We'll try that in a second after we finish this. But I'm trying to remember for the
I
fun of
put
it, I'm just gonna do this.
25 into a long and see if that works.
I'm gonna turn that's a long. We're gonna turn this into a long because that could also be a long, I guess, potentially. Just for the fun of it, let's just find out. Make sure that still works. All right, loss of conversion. I'm gonna turn this into a long. Sure it works. It does work there. Yeah, I thought so.
nice.
So it's this guy that's getting big. Yeah, this one's getting big, and possibly this one too. So these two have the potential to get really, really large.
You still have to
So that's what
typecast it though into an int? Does it? Why is that?
Yeah, but well, again, the typecasting in this case is just to let the system know I am aware that I have potential loss. I know that I am downcasting a number. And so what I wanted to showcase is, this is one of my favorite little videos to do. Understand it's, and actually what I want to say before we get into it, before I actually show it, is that there was actually one of the students that actually went to eMoney benefited from this video. the student actually ended up asking me for the video after he got hired. Like, hey, I need that video that you guys showed us from Super Mario baking a cake. I'm like, what? It's like, I'm like, what? So
Well, I think I remember this one. I haven't seen it in a while though.
I remember this one.
Yeah.
some of you might remember it. Yep.
Yeah, I remember. It was a good video.
Hold on 2 seconds, and then I'll see if I can how to share the audio so you guys can hear it. Let's go trial. Pause. Pull it back, and then play.
Well, I think I mean, you can look it up, but I think how you do it is before you share your screen, there's like a little thing you check to share audio.
Oh, let's try that. Okay.
I
We'll
think
try
you
that then.
can, can't you
Share.
change that from the?
Ah, there it is. Share sound. Good call. Ah, dang it.
You know, his password 7 digits long.
Can you hear this?
No.
Uh,
I get.
Jim's crazy.
You guys are definitely lower sounding to me. So video clip, share. You guys still hear me?
Yeah.
I can still hear you.
Can you hear this?
No.
No.
No?
See if you can change it from your mute button.
Select the speaker, same as system. Oh, that's the speaker thing.
was the thing you shared like clicked said share sound? Did it say that?
Yeah, right here, down the bottom. Oh yeah, you can't see that.
No,
Yeah,
but
I'm doing the share thing. It says share sound checked, optimized for video clip. I did that.
Oh.
I also checked that one. Let's try this.
Check under the mute button and see if you do.
no.
Might be able to just like try a new browser session or something.
Oh, like instead of the entire desktop, just share the
Give me 2
browser.
seconds. I'm gonna reset Zoom because I had to give it permission. So first person on the list. I'm gonna make you co-host for a second. Leo, you're a co-host. Hold the fort while I restart. I'll be right back.
Okay.
Stop share. Leave meeting.
Yeah.
You get my
Oh,
message, Rob?
it's in the share. Stop sharing your screen and then reshare it. And there's a pop-up window where you select your desktop and there's a checkbox in there that says share computer sound.
He's not here.
Did he go? Did he leave?
Yeah, because he's restarting his Zoom.
Cliff's gone. He said
He
Alita's
didn't
gonna.
have to do that. He didn't have to do that. Nope.
All right, guys, I'll be taking over from here.
Okay, so what are we doing?
So recursion.
What are we doing here?
Do recursion.
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 Can you give me in 2 minutes? Can you give me your best explanation of recursion?
I'm back.
It's to give you the best explanation of recursion.
I took over last Cliff.
But that was short.
What's that?
Last, but now it's back to you.
That was short-lived.
All right, let's
Yeah.
see. Share sound. Share. All right, let's test.
Fact.
Yeah.
This
There we
time
go.
we're going to talk about
Can you hear it? Okay, let me restart then. All right, so I'm going to speed it up a little bit. If it's too fast, let me know. I'm going to go to 1.5 so that we can get through it a bit quicker. Because the overall importance of this does make sense. Talking about data types and why do we care about between int, long, and all that stuff? What does it matter?
What's up, guys? I'll be honest, I didn't expect to really make a sequel to the 416-year block video, but it turns out there are numerous counters in Paper Mario that the developers didn't limit. So here we go with another Paper Mario fun fact. This time we're going to talk about ovens. Following the fight with General Guy in Chapter 4, there's a little segment where we play as Princess Peach, which requires us to bake a delicious cake for Gourmet Guy. It's not challenging by any means, but if you use the incorrect ingredients or cook it for an incorrect amount of time, Gourmet Guy will spit it out and send you back to bake him a half-decent cake. But the question is, how long do we really need to cook it for? Well, they tell you to cook it for 30 seconds in the cutscene dialogue. Obviously, they don't expect everyone to time it at exactly 30 seconds, so we discovered you have 690 to 1080 frames to take the cake out of the oven. Paper Mario runs at 30 frames per second on the NTSC and JP versions, and regardless of what release of the game that you're playing, this room doesn't have any lag. So we can divide these numbers by a clean 30 to get a range of 23 to 36 seconds. That's how long you have starting from the moment the ticking begins and ending when you press A to stop the timer. Stopping the oven when the counter is outside of that range will cause Gourmet Guy to question your cooking skills when you deliver him the cake. However, as I said earlier, the developers did not set a cap to many counters in this game, this one included. The number of frames you've left the cake in the oven is stored in the game's memory as an unsigned 4-byte integer, which means it can be a value within the inclusive range 0 to 4,294,967,295. Should the value continue increasing and exceed this limit, it will loop back to 0 and continue counting up after resetting. This is known as an integer overflow.
Everybody catch what happens there? So think of it almost like the old school odometers or odometers on cars that actually had the physical wheels. Once all the odometers had 9, if it flipped again, all the digits would turn back to 0. So that's kind of what's happening here.
And exceed this.
Slow this down so you can actually see the timer a little slower. That back to normal speed.
Limit, it will loop back to 0 and continue counting up after resetting. This is known as an integer overflow, which isn't really anything special, but it does mean that if you bake the cake for, say, 4.3 billion frames, the game would incorrectly think you've only been cooking it for a little over 5 million frames. Remember, the maximum possible value in frames that the counter can reach is this number. Add 1 and divide that value by 30 frames per second, and we have the number of seconds until the overflow occurs, where the counter is set back to 0. If we continue to divide this number to simplify how much time we're working with here, we reach a value of approximately 4.5 years before the counter overflows. So if you leave the cake in the oven for that long, then wait another 23 to 36 seconds before taking it out of the oven, you can deliver the very overcooked cake to Gourmet Guy and he'll eat it with no complaints. If you didn't notice, I was waiting at the oven for longer than 36 seconds, yet Gourmet Guy enjoys my cake. This would have been impossible if the overflow didn't take place. Now what if we wait for it to overflow more than once? Again, the counter will reset back to 0, and Gourmet Guy will accept your cake even after cooking it for 9 years straight. This also means the cake will be considered delicious approximately 13.6 years after being left in the oven, 190,852 years, and so on. Another counter overflow can occur in Princess Peach's castle at the very beginning of the game. There's a cool little secret here where if you talk to this toad, he'll explain that he's guarding Princess Peach's room during her party. Talk to him 5 times, and he'll give in and let you explore her room. There's nothing terribly interesting in there, but the counter that they use to track how many times you've spoken with a toad is glitched. If you speak to him from the left, he'll move towards the right after granting you access. For some reason, speaking with him 21 more times causes the counter to jump up by over 4 billion. Here we can witness a realistically achievable overflow where the toad grants us access once again even though he already has. Then he'll just move to the left and the counter will cap off. By the way, if you speak with this toad from the right at the beginning, you might be surprised to learn that everything works as intended. Hopefully you guys found this video interesting. If you did,
just a weird bug, that one. If you talk from the right, the integer overflow doesn't occur. Talk from the left, the integer overflow occurs. So this is an interesting concept. It's not just integers. Any data, and so even the long can have a long overflow. They just tend to call it integer overflow because a long is still an integer. It's just a really big int. And this is a really key thing to keep in mind when dealing with things like Java and any sort of these hard typed languages that have these data types. When you hit the max cap of a number that can store and you add 1 to that number, it'll just roll back to the zeros. Because what's happening in the memory, just to keep it simple, pop back over here for a second. Remember, all the numbers are stored in binary. And how binary works is you have the 0, 1, 1, 1. If I add 1 to this, I try to add 1 here, it's already got it. So that rolls to 0, carry the 1, rolls to 0, carry the 1, roll to 0, carry the 1, and then we have that. With this number 1, 1, 1, 1, when I add 1 to it, what the computer does, it doesn't know every memory spot. It doesn't know that the whole thing's full already. All it does is say, okay, well then add 1 to this digit, rolls over, add 1, roll over, add 1, roll over, add 1, roll over. And then it theoretically it does add 1 to the next digit if it has write access. If it doesn't have write access, it doesn't change this bit here. It won't change it, but the system is only looking at these 4 digits, these 4 binary bits for the number. Again, in your actual integer, you're working, I think, with 32 of these, but I don't want to write 32 ones, so please forgive me on that. I don't actually want to write an actual whole giant integer number, but this is all it sees. And see how it went from 1, 2, 3, 4, what is it? 1, 2, 4, 8, 8, 9, 10, 11, 12, 13, 14, 15. So it went from, doesn't sound right. Hold on. 1, 2, 3, 8, 9, 10, 15. So it went from, is that the number 15? No, I thought it was 16, wasn't it?
1, 2, 4, 8, 16.
2, 4, 8. Yeah, the next one is 16, right? Yep, so that is 15, yeah. So this equals 15, but by adding 1 to 15 on a 4-bit integer, we then went back to 0. That's what the system sees, and that's an integer overflow. What ended up happening with the student that I had that went to Virgin Pulse, sorry, he went to Virgin Pulse. Virgin Pulse had a tool where you would, their whole thing was counting steps for a company, was one of their things that they did with the company as a way to promote good health practices for their employees. Employees were incentivized to wear a pedometer and count their steps, and they could earn points and get like gifts and prizes and put into raffles. And one thing they implemented for certain companies that they could do department scores or department steps, so that departments could compete against other departments or other locations. So the Rhode Island office could compete against the Washington office to see who gets the most steps.
It sounds like an episode of The Office.
What's that?
It sounds like an episode of The Office.
I could see that. So the idea here was, yeah, the offices were competing on who could get the most steps. And what they were finding is that the numbers weren't totaling right. So they were looking at it, and what was great is that none of the, when our student was in there, creative student was in there, he'd only been there for like a couple months so far, but he suddenly remembered that video. He's like, wait, why are they storing these numbers? And he looked, and they were not storing them as the right end, because yeah, as individuals, they had a nice number. An individual hitting 4 billion steps was difficult. But having a company, when you aggregate or load up all your employees' steps, that could easily go over the 4 billion integer limit. And so he's like, oh, when we combine them as a company, we're overflowing, because they had a signed in, so even negatives were even allowed too, I think. And so yeah, he was like, oh, overflow. So he showed everyone, and it was like, how did you figure this out? Like, he had other people there, the interns were working on it. Like, all the interns tried to figure it out. I was like, honestly, it's because I realized you could bake a cake for 4.5 years. So yeah, he asked me for the video so he could share it with his coworkers. It was great. But this is something you want to be aware of in the language you're dealing. Now, JavaScript has a data type called number, and it will automatically, if it detects you're about to overflow, increase the amount of bytes it uses. Java doesn't do that. Java has a strict data type system, so if you do go over, you will overflow. That's what's happening here. What's happening in this system with those four edge cases is that our number is larger than an integer could store. So we went to that max and limit, added more to it, and rolled back over to the beginning, so our number went low. So we're getting the wrong result in the end. By making long, we can store a longer number, or a larger number.
The other thing they also say is that long is a 64-bit digit and an integer is a 32-bit digit.
Yeah. I wish I could remember one thing too that they did. I'm gonna have to search for this video because it's a CS50 video from a while ago. Again, just being aware of what things can do.
I'm wondering, like, if like using long with a 64-bit number, if we're doing mathematical equations and it gets even bigger, like, can we overflow that? And then, like, what are we supposed to do then? Like, as it gets bigger and bigger and bigger.
So you can use long, that's even longer.
Mm-hmm.
I don't know if you can go any longer than that.
Right.
I think, well, double, I don't know how far doubles will go.
Right, double.
Oh, what was the thing?
But since we're using,
I'm sure there's some language that deals with irrational numbers, you know, numbers that go on indefinitely. I don't know if Java is that, but I'm sure there's out there.
So I gotta find the video of it because I'm having trouble remembering it. But there are reports of like certain situations that happened where programming and using the wrong numbers using precision can make an issue. Where precision or decimals and stuff like that can make things too. So we've talked about precision with decimals, something else to look into with that. Be good to know about how when doing math with decimals, computers have struggled with that. One of the situations with that,
it's pi because it goes infinite.
yeah, but So what it is that there is one of our missile protection systems that we used in the past for catching and taking missiles out of the sky. We used a tool that would actually, it would be a detector. We would tell it that there would be the alert that a missile went off. So what the scanner would do, it would scan the skies and it would find a object. Wouldn't show what it is. But if it was a missile, it would know that a missile flies at a certain speed. So it would be like, oh, I see a missile here. If it's a missile, it should be here after a certain number of time, after a certain number of clicks, at a certain timestamp. And once I see it, it should be here. If it's there, then I know it's going at a certain speed. I know it's a missile. I need to target that to then shoot it down, to then launch on the missile, take it down. Notice how I mentioned time. So when it notices the missile, it says a timestamp and then checks it. The problem is that these systems had a memory leak in them. And what would happen is that when left powered, the clock would start to lag. 1 second was actually not 1 second. 1 second would actually take about, for the clock to go up 1 second, it would actually take 1.1 or 1.2 seconds, 1.3 seconds to count a second. The longer the system stayed on. All you had to do to keep this from going is just turn off the machine once or twice. Just reset the machine and the clock lag would reset. The memory would clear, the lag would be fine, it would be able to count a second normally. Apparently one of these scanners was left on for several months. A missile was launched, it was recorded, it noticed the missile here, it waited the 10 seconds or whatever it was, checked the spot, and didn't see the missile because what had actually happened is that 12 seconds or 13 seconds had actually passed. And so the missile was over here instead. So the scanner didn't see the missile, figured, oh, it's not a missile, it must be a bird or something. It's going slow because I didn't see it. And so it didn't launch the protection system, and it did actually crash into its target and killed a bunch of people. It was a very unfortunate, bad situation. But this is things that can happen when programming is done incorrectly. When you're not paying attention to memory space, to those things. Luckily, none of you guys will be working on something that is going to put people's life at risk, at least hopefully not. The companies we're putting you in are not security systems or defense systems.
You're all gonna die.
We'll just make mistakes for bank accounts, so someone will get like $10 billion because we just admit an error in our math.
You made an error, and when the next time they swiped the charge, instead of going to the negative, they rolled into the max value.
When that airplane crashed, the Boeing 737 in Egypt.
Yeah.
The other one was Malaysia.
Mm-hmm.
Was it? It was one of them.
I think there was a programming issue. Yeah.
Yeah, it was a software issue.
The way that the pilots were fighting it, the plane thought that it was actually drag, and it was so it didn't read the pilot as a pilot. And
bringing the nose down, which I was like, man, I bet that's a software engineering problem, and it was.
100%. It was both. It was a software engineering issue and a training issue. The pilots weren't trained to realize what the computer was doing, and so they didn't realize that what was happening was actually the program doing something for them. So the pilot was fighting what it didn't realize was actually fine. It thought that something was wrong when it was actually the program trying to just do something for them. It was trying to handle a part of the flying for the pilot. Since the pilot didn't know it was doing it, the pilot thought that something was wrong with the plane. And so the pilot was fighting the programming, the program was fighting the pilot, causing this go down. So it was a combination of both. There was no system in there for the system to realize that the pilot is not letting me do this. I should let the pilot do what it wants to do. So there was no way for the pilot to override the system. And that was one of the biggest, that was the programming issue, but the other issue was the pilots weren't trained to understand what the plane was doing. And so it was a bad situation on all cases. So we've had this happen due to precision with variables. We've lost space rockets. We've lost space rockets due to imprecision with decimal points and stuff like that. So there's a ton of examples out there where you can see like poor programming caused actual loss of financial value, loss of life, which is the worst case. Which is why it's good to at least just have in the back of your mind, be aware of like how much memory you're using. Are you causing a memory leak? Why you're processing? This is why having good, clean code does make a difference. It helps to prevent things like this from happening. Of course, you get the fun ones like you saw with baking a cake for 1,000 years and it's perfectly good to eat, even though that thing would literally be ash. The person eating it thinks it's great. Space? It's been a long time since I watched it.
But they put it into the program to take 0.000001 out of the accounts of everybody. So eventually it built up because they took out like such a minimum amount, and it was less than a penny, but they built like millions of dollars off it for a while.
Yep.
What is it, like a YouTube video or like a?
Office Space is a movie.
It's a movie.
Yeah.
I'm gonna have to have you come in on Saturday.
Stapler. That was my favorite thing. Stapler. I'm gonna burn this place down.
Oh, the red
Anyway.
stapler. Yeah, you
Yep.
can't take my stapler.
Yep. Anyway.
Listen, we need to talk about your flair. I don't think you have enough pieces of flair.
Yeah. Right. Yeah.
Those of you who haven't watched it, everybody is just like, what are they saying?
Oh, that whole thing is just.
Have you seen my stapler?
Yep. He was my favorite. That was my favorite. That guy was my
Hey,
favorite.
fun
I
fact
liked him.
about that movie, you know that they didn't make red staplers when they were making that movie, so they spray painted that stapler red. And then after
And
that
now it's one of the
movie,
most popular staplers now.
right,
Yeah.
everybody's looking for that stapler in red.
Yep.
It is.
Everyone wants red stapler now.
I can see the meme that came from this movie. The guy
Oh,
with the
yeah.
glasses holding the cup.
Mm-hmm. That's him. Yep. That's the.
That's
I'm gonna
that's
need you to work on
Lumberg.
Sunday. Yep.
Yeah.
Yep.
Which
There's
is
a bunch of memes out of that one.
CBS reports.
Yep. So anyway, main thing to keep in mind here again, the funny thing about it I want to make sure you guys see on this one is this was a medium level algorithm, but how quick did it take us to solve this? This is a fast one, right?
Yeah, it was. Pretty
Yeah.
If you understand how recursion works, if you can see how the recursion works and how you can benefit from it. And again, just this idea, and I want to keep putting in this idea of kind of pulling things apart. Superdigit's main goal is just to decide whether or not the digit is a superdigit, or to call again. So all it does is says, hey, make this an array, get me the total, and then is this a superdigit? No, do it again. Once I have the superdigit, I'm good. Again, this is something that I feel like could be done in a for loop, or just a while true loop. So just for the fun of it, I'll do this.
Instead of that if statement, I wrote if new r oh wait, that I'm reading my code, but I wrote if the string length is greater than 1, then I wrote the for loop.
Yeah, we're just gonna do this. Total. I'm not gonna do it. Yeah. Oh, yeah. I can't do a base case. I can do a do while. There we go. Actually, never mind. Do. 4 is greater than 10. Total equals. It's. Ooh, that's so my biggest problem here would just be the K. How are we dealing with K? Oh, I got an idea how I can do it. Calculate digits. Okay. K is greater than 1.
Cool.
Oh yeah, thank you. Okay, and then that'll do it. So this would do the, I think this should work the same. So long total, which will start at 0, and then total equals the calculated digits times K. If K is greater than 1, we're gonna set K to 1, because we've now used K once at this case. Because of the do while, we're gonna run this at least once. So we're going to pull K, and then we're gonna set K to 1 for every future iteration, which is what we did here by doing this.
You
That's
either
what
gotta print
the,
it or return it.
I know, I'm gonna get that. I'm gonna put that back. I'm gonna get that in a second. There we go. If total is greater than 10, we're just gonna repeat and do the same thing. Total equals, oh wait, that's not gonna work right. And then you do. So this is where you're starting to see a little bit of the benefit of the recursion here. Getting it to use the same thing. So I want to use digits again. So I can do this. Hold on. Not that. Oh, Jesus Christ. That.
How did you do that? Copy this thing right down.
Holding down Alt.
Alt. Oh.
Yep, Alt and arrow keys.
can also highlight and use your mouse to drag it around, but it looks like Alt key is a little bit quicker.
Not the most clean thing, but I'm going to reset digits now too to the new total. Not fond of that, but it'll work. Which I guess I could always just do this actually. You know, actually I have a better idea. That. Now I'm going to do while. Let me do while, just do while. Total 10. Digits equal this. Paste equals that. Okay, anymore. That should do it.
Get rid of your
Get rid of
while.
the second
Oh,
while.
yep, thank you. I totally saw that as soon as I hit the button.
While. Do the while.
Yeah, while. What am I missing here? String cannot be converted to it. Where is that?
41.
41.
Oh, it's already a string, isn't it? No, it's not. Wait, what?
It needs to be returned as an int. Oh, but that should yeah.
I don't know why I did that. I'm good. There you go. Oh, because it was inside the return subdigit. And then, oh yeah, I got to do the int. Do that to make it understand that I know that I'm shrinking my binary. If any of those binary digits outside of the int are ones, I'm losing those. So it still runs, still works, and it still passes all the test cases. So as you can see, I can do it with a while loop as well as recursion. So do be aware of that. It's definitely doable. I do think that the recursion had the cleaner code because of the whole K thing and stuff like that. So I do think this actually had cleaner code. Only had 4 lines there. This is a little more having to finagle the digits and having to run it once outside. And so I do technically have a little bit of repetitive code here. I'm running calculate digits again. So it's a bit of repetitive code there. But it is doable. And that's what I want to showcase there. A lot of time there in this one, we weren't really taking advantage of some of the other benefits of recursion. We weren't taking, once we do the flow back up, we weren't doing anything. We were just getting the result each and every time of this and just putting it here. We were just getting the result of this line, turning it, returning it up, putting it there, returning it up, returning it up. There was nothing extra done after this return statement here. So it's a base case or do the same method, nothing else. Which this is the case when you're seeing something like this, when there's nothing after a recursive call, when there's no additional information being happening, where you have to do something after the recursive, it's very likely that you can convert it into a normal looping structure. What I mean, like instead of doing a return subdigit, if I was going to call it, save it, total, and then do additional logic, then return, that's where recursion can have a bit of a benefit because I can do some stuff here after I do the recursive call on each and every iteration. On each call, on each return from each iteration, I can do some additional logic, do some additional things if I need to, instead of just going all the way back up the chain, bing, 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 bing. What I'm really doing here is I'm just creating a domino set that as soon as one starts falling, they all fall at one time. There's nothing else happening. What recursion gives you the ability to do is, yes, when you start the domino train back up, the dominoes can fall, hit one, stop, do something else, and then go back and then continue up the chain or even set up new dominoes instead of another path. That's where the power of recursion really comes into play, is that concept. When you start that domino trail back up the chain of calls, recursion has the ability to take one of those falling dominoes, not fall immediately, and do other actions. Either do more stuff and then continue the fall down and continue the domino chain, or set up a whole new path of dominoes that can then fall back again. So that's really where the power of recursion can come into play, if that makes a little more sense. Again, I'm definitely gonna give you guys a couple more recursion examples that'll help you to see where the benefits of recursion come into play. I'm gonna look into some of those. They'll be a little difficult. But hopefully you were able to see here how this one wasn't so bad. Once you understand recursion, come up with your base case. That thing that says, hey, we're done. We've hit our, we don't need to do any more recalls. We got what we want. Send it back. Otherwise, keep doing the same action. Sound good? Any questions on this?
I have a question.
Go for it.
Is there a way to solve this without creating that function, calculate digits?
Oh, of course. I can just, where you see this, I can just put that right in this place.
Okay.
So instead of using sum, I would just do total. So I would just do, for example, copy, get rid of that. Paste. Total equals that, and then I would do total equals times equals k to do the k thing, and then I would just have to do the same thing here though, and that's where the function for me made sense.
Okay.
Yep. Now I'll do the same thing here, do that. And now I would do total, and I'd have to reset total to 0. So I'd have to set total back to 0, redo the for loop a second time. See how that works?
Yeah.
So that's why I like the extra function.
Yeah, it's way cleaner, and it makes it more understandable too.
Oh, but good question. That's what I want to make sure you understand why I do these things, why I have the extra function, the extra method. It's an extra method just because I figured I might need to use it in multiple places, and really super digit doesn't tell me that it's combining digits together, right? That it's calculating the digits. So I felt like this made more sense. Like if I knew I was doing something wrong with the calculations, or I wanted to change how the digits were calculated. Let's say they changed this, instead of adding together the digits, they wanted to multiply the digits together. We could easily just come into here and just change this one line here. And now our method's changed.
Yeah.
Now we're multiplying the digits together to find a single digit, which I actually think won't work because I think we'll always end up with a larger number. So I don't think that would work. Maybe we would do division. There we go. We could divide each number by the next number, which will probably just end up 0. So you get the point. If we wanted to change how the digits were being done, let's say we wanted to do every other digit. For example, there's a good example. If I wanted to add every other digit, I could switch this from a for each to a for equal 0 or 1, 0. Not less than, what's length? Equal 2. And so I would skip 2. So I'd skip one number. I'd take one, add the next one, and then here I'll just do digits. And see how that would change it. And so now I just changed how the calculate digit works without changing super digit. Super digit still behaves the same. We're still looking for a single digit. We just changed how we're calculating the digit. And it updated both locations here in one shot. So that's the other reason why it's good to have a separate method, because you can easily update a specific item and you know where to look to do that update. It's like, hey, I want to change how we're adding the digits together. Oh, I'm just going to go to my calculate digit method. I don't even need to look at super digit at all. Make sense? Cool. Any other questions?
Do we have time to go over the warm up that we did the other day? Because for some reason I wasn't able to pass all the me and Jim was working on it. We wasn't able to pass all the test cases on that.
857. Let me see if I can give you some pseudocode. Hold on. Let me take a look at it. See if I can give a little hint. Hurdle race.
I could show you what we have too so far.
That might
Spent
work.
a decent amount of time with Jeremy on it.
Yeah, this one's ranked easy, and then I feel like it's harder than the recursion one.
Oh wow.
Yeah, it was just we could get the answer, but it's just pulling the answer out from the lot of everything was in front of us to get that
Yeah,
one.
me and Richie killed that one. Murdered it.
Yeah.
You solved it, David?
I said me and Richie murdered that one.
So you solved it?
All of them? I think that's what
Yeah.
he's saying.
Hello?
Yeah.
Yeah, I passed
Really
all of
crushed
them.
that one.
Oh, got it. Killed it means
Yep.
okay.
Yeah.
Got it.
Oh, the hurdle. No, that's not the one.
Yeah,
Minimum.
this is the, oh no, that's the older hurt. That's the other one, right?
Richie, let
Hold
him know we killed that shit.
on.
Richie, I heard you killed it.
Yeah, we killed it.
Yeah.
You heard correctly.
All right, cool.
Well, what we could probably do to make it quicker is Joel, have you show what you did, and then either David or Richie can show what they did and see the
Yeah.
difference.
All right.
Yeah, let's do that. That way we can do enough time. Because I know
Alright.
I know Alita usually has to jump out at 9, so we'll see how long she can stay. Go for it.
I have to join from my computer.
Yep,
but-
I'm ready for you.
All right. Good.
I'm waiting for it. All right, Colin, go for it.
I'm in.
I'm already recording. I didn't realize I still was. Cool.
Did you let me in, Cliff?
Are you in the waiting list? I don't see you.
No. Oh, weird. Let me join one more time. Open link. All right. Good. There we go.
Not getting the ping yet. I'm the host, so oh, there it is.
Okay. Maybe just coding problems. Maybe.
Probably. We'll see though. I like the idea of having you tell us what you have and seeing if either David and Richie can either tell you what they did differently or what you're missing, or see if any of your classmates can tell you what you're missing. So everyone's open to say, oh, this is what you're missing. If anyone can figure it out.
All right. Let me just exit this out. Where did I write this? No. Solutions. No, this is 30 days of Java. All right, right here. So this is pretty much what I have. This
Walk us through it.
all right, so basically it's a nested for loop, and it's basically going to check if the current index is equal to the next index. Then we're going to minus the next index minus the current index, and then we're going to add it into our list.
Mhm.
And then at the end, we're basically gonna grab the min from the list, and if min is equal to 0, we return -1. Else we return basically the absolute value of what the min is. So I could actually just write min here, right? Because I'm doing it twice. Yeah. There we go.
So what we're doing here is you're looping through. So one of the main thing is you're looping through the array, trying to find a duplicate from where you are forward. So you're not looking behind it, which is great. I do like that. I see that. You're always going from the current item forward, and as you move forward through the array, you never look back because you've already done that number. So good there. When you find a pair, you take the 2 indexes and subtract them. Right?
Yep, exactly. And then
Gives
I
you a
added
difference.
to the list here, and then this is how I check basically if I should return -1 or the
So I'm
number.
curious, is there any reason for you to maintain all of your differences or just the smallest?
The smallest, and then just do like a math, like a math.min. Oh, sorry.
You can do that or just compare the two.
Yeah, I was trying to figure that out, I can figure out how to always keep running total of the highest, but I'm having a problem trying to keep a tally of the lowest constant.
Yeah,
The
give
making
it,
it's higher is
give it
always
your
gonna
current
be-
min and then the new min. So you do min comma difference and make that min equal to that.
Then we pass in difference.
Or you could just store them all and then sort.
But again, why take up all that memory? You have no reason to store them all.
So
That's
then
honestly just a waste of memory.
min
Min equals, just keep track of your current smallest.
difference.
Why store all the differences? You have no reason to keep them. They're no way asking you how many pairs were there and how many different differences. All you care about is the lowest minimum, or the lowest difference.
So basically, min. So
And you might want to do ABS on some of the difference.
on difference
Yeah. So that way the result is always a positive number.
number. Yep.
Mhm.
Got it.
Yep. So it's always positive on both cases. And that means you wouldn't need to do math ABS on line 112 anymore.
So I wouldn't even need this already.
Yep, nope, don't need that at all. And so yeah, get rid of that line. And then on line 108, you don't need to do math ABS anymore.
108. I don't need to do my. Yep, I just need
Because
to.
you're
return.
ABSing it. Yep, you just return min.
Yep, that's
And
it.
also get rid of that else. Why are you doing an if return, else return? If return, else return. Don't need the else. Just the if statement's all you need.
Yeah, it's just habit, I guess, from Java.
Oh, I know. I'm trying to break the habit.
But it doesn't like that long, so we need to cast it to in.
Yep, you need to cast it to take advantage and let it know you're aware that you might be losing data.
So let me see if I can try to run this.
Again, always be aware. Do I need to keep track of all this information? What do I need? What is the information I care about? All I care about in this algorithm is the minimum number. I don't. If I find a difference that is bigger than my current min, I don't care. That stuff means nothing to me. So I'm going to ignore it. That's the idea here. Keep that, consider what would happen to your phone if, as Google Maps is trying to map out the best route for you, it kept track of the time for every single route, including the routes that took 2 times as long as your other ones. So it decided to create an array of all the times from getting from point A to point B. And as it did its kind of crazy, checking out every single path, it would use storage space in your phone to keep track of every single possible timestamp instead of just always remembering the shortest strip, the fastest strip. You would be upset if your phone was if Google Maps was taking up all that memory in your phone, right? When your phone started to lag and slow down, it would slow down. It would actually slow down Google's result attempts probably too, as it ran if your phone started to run out of memory. Like, who's here? Has anyone here not used Google Maps for a trip longer than an hour? Everyone here, I'm sure, has at least used Google Maps for a trip for an hour long, right?
Mm-hmm.
Well, imagine how many different varying pathways Google would have to evaluate to find that best path for an hour, right? Consider all those different branches, right? What's that?
I've done one longer than an hour.
Right. I'm just saying at least an hour.
Yeah.
And I'm just using that as my base example. For that 1 hour trip, consider all the side roads, all the different varying pathways that Google Maps could recommend as a pathway. Imagine that every single one of those pathways, it decided to keep track of every single path, even the ones that took longer than its current best. That would just be a waste of storage, right?
Yeah.
That's kind of what we're doing here. But we're taking up memory in this. We're just kind of adding extra calculations to our system by storing information we honestly don't care about.
417. Okay, so let me see what we get with this. Well, actually, and then we pass in the array, right, which is
Distance.
And then that's it, just one parameter.
Well, you still got to print out the result or something. So if I would do system.out print line.
All right, let me just so I know what I'm looking at here.
No, on line 19, you just want to print the result.
Okay.
Yeah, we're getting the result where the code's running, but you're just not displaying it.
All right, then I clicked on one too many things.
I don't know what you did. You did the split vertically, and it's not happy with that.
Yeah, not at all.
Nope. It is angry with you.
Never happens.
Yeah.
Oh,
It's crashing.
the shade of death.
Oh, there it goes.
They're responding.
Okay. Weird.
Yeah, yo. They're gonna have too many tabs open and stuff. I don't know.
Possibly. Line 19, just add a system.out, the system print line.
Line 19.
19, yep. Why do we yeah.
What
And then
am I
the result of line 19. Sorry. I want you to print out the result of line 19.
Something's not clicking here. What do you mean the
You have to
result?
put it in front of solutions, man.
Just put the whole solutions dot minimum
This,
distance in
you're
the
running
now.
you're running it, but then you're taking that number and just chucking it into the bin.
Gotcha. I don't know why I wasn't clicking. I'm like, wait, what?
Yeah. Now go ahead and run it. -1, so it doesn't see anything. Why?
Because
Wait,
it
is your
min's
min
already
set
set
to
to
-1?
0.
Well, yeah. Oh, right. So that's the stupid thing with min. You need to set it.
So-
You need to do an if statement to see if your min is 0. Not there. Hold on. What's happening
No.
is that on line 108, I'm sorry, 100, it's always taking the 0.
I have a suggestion.
Go for it,
Well,
Christian.
I could submit it
set-
to 1,000.
set min. No, because what if?
1,000. What if that is your
Okay.
minimum? Yeah.
I
Yeah,
think it,
so the
I
issue,
think oh, sorry.
Hold on.
It's 105.
Go for it,
yeah.
Christian.
so the issue if you set it to a constant number is what if the distance is smaller than that? I mean, is larger than that? That's
Right.
actually the distance because
So
there's a,
you should set it to integer dot max value.
Yeah, no, I think this worked. Let me
It will for that example. Hold on. Stay with us, Joel. So what we're saying is that you have to consider all possibilities, every single scenario. So let's say I give you an array of 10,000 items and the first number and the last number are the only pair. Now your distance is 10,000. Your system can only handle arrays of maximum length of 999.
Yeah, I think I read something yesterday here that said like
Right.
the constraint was 1,000. So
The
that's
main
why
item, the biggest issue we have with Java is that numbers can't be null or undefined. When you initialize a number, it's automatically defined to 0. What we could do, of course, is I do believe there's a max value constant. So that's one of the workarounds for it is you can use the long max value. I would have to take a look at the Java of that is. The other thing you could also do is above min. Before doing this, you could do an if else, where if min is equal to 0, take difference, just set min to difference.
so.
So that
once
does
he's
the
finished
initial
with
set.
that, can I ask a
Yep.
question?
Oh yeah, of course.
I'll wait till so he's. That's,
if then
If
I
min
would-
is, you could also do if min is not equal to 0, set it, but yeah, if min is equal to 0, min equals distance. Absolute value.
equals distance.
Yep, and just do math.abs on that before you do it though.
All right.
That'll handle our base case that the 0 there. So now our current line 108 still works.
Yeah,
Why is
Well,
it
not
yellow?
distance.
different.
Difference.
Oh. Sorry.
No,
I
I
say difference.
I should pick that up. It's fine. I do mistakes all the time.
Yep. That way, again, if you don't find any matches, you keep that 0 number. That is your base case. But otherwise, if we do find any distance at all, that becomes our initial min.
Can I ask my question?
Oh, also, I would change line 94 back to min equals 0. Sorry. That's why it's currently working right now. That's still going to break. Sorry. That's going to be back to 0. There you go. Make sure it still works. Yeah.
Check it. Turn out 3. Yep. Turns
Yep.
out
All
3.
right, so then go back up. That's why sample case 1 probably broke. Code. And there we
There
go.
we go.
Submit code. Why are we
Ooh,
still filling some?
Yeah, these were still the same ones I was filling, right?
Huh.
Jim, these are the same ones we were
Yeah,
filling.
these
the other
were,
time?
yeah. The other
Interesting.
you got 3 extra cases we didn't have. You ended up getting 2 extra ones. You got
Don't
7
look at
extra.
that. I don't care what the data set is. I want to know what the expected and what you sent, what you gave. So scroll down to the
Hey,
expected.
that's the thing with this. It says wrong.
Right,
answer.
scroll down to the output.
Yeah, the output only shows you what it's
Expected
supposed to
is
be
180,
expected.
190. What did you give? What's your
Yeah, you
output?
gotta. Put
Yeah,
that, you gotta put
that's
the
the-
custom.
Maybe
custom
I
set.
could put like a SUT out and then just let us know exactly what min is.
It's
Right.
not going to give you the outs on the submit code for some reason.
No, you have to put that into the
Usually
custom code just to see what the custom.
You have to
input
spend
particular
hackles for
input is.
those.
Mm-hmm.
He did. That's why we can see the input. He spent hackos already.
So submit.
Oh no, that's not gonna. I think I know what one of them were saying. Go to that tab you opened
Yeah,
right there.
This top
Yep,
one.
click on that. Yep. Copy all that. The whole thing, including the 1000 at the top. That too, yep, copy.
And then I know.
And then do test against custom. And our expected output is 190. So run it.
190.
Scroll down. You didn't find it.
this is what we were having problems with these big sets. We were still getting like
Yeah.
zeros all the way across.
Yeah, that's why I didn't understand. I was like, from the
Wait a
beginning,
minute.
this is such an easy problem, and then
Yeah.
I didn't get. I got like.
Can
half the-
can I,
Wait, I think I just
Yes.
thought of something. Go for it, Christian, though. What do you think it is?
I don't know if this is actually gonna fix this, because I did it little differently. I just had a question as to, instead of setting min to 0 and then checking within the if state, within the for loop, with it being a nested one. If you set
Don't make any
min
changes
to the
yet.
length, if you
Yeah.
set min to the length of the list, it's always gonna default to the longest possible distance. And
That's
then
not a
you
bad
can
idea.
always check the
If
minimum.
min is equal to
after.
length. Yeah. And then
Uh,
here
then
it's changing min
minus
is equal to
one?
length.
Is
Yeah.
it size or is it size? minus
Size,
one?
size.
Oh, two size. Okay.
And
And then
then
we could do the same thing here. If min is equal to size.
um,
Oh, should we
Yeah.
do size plus 1 actually? Or no, that shouldn't be it. It's
Oh,
0
no,
and then
size is already
equals
plus 1.
0 if you're
yeah,
setting it
you're right.
for
You're right.
loop.
Yep, good. And 0. Then you go to that. Yeah, so yeah, you'll always be 1. Your maximum distance would be -1. So that would work. But then one other thing I want to mention, by the way. So our mid is a
Oh.
long, right? Take a look at line 99 when you're doing the difference. What are you storing it as?
Ooh,
I think we're just doing we're just getting an integer overflow there again. Those are really big numbers, so even our difference could end up being big.
So let's try.
Also, why is he doing a nested loop?
What is the maximum number of items in our, anyway, it's fine. Keep going, go ahead,
Oh.
try that.
Why am I doing a nested loop? Because it's just
No,
like
no.
more solution to trying
No,
to
the
solve-
nested loop is correct.
Yeah. Oh.
Yeah,
You can use a hash map, but
I didn't use a
down.
nested loop.
nope, still didn't see it.
Still -1.
What's going on there?
I think there's. So you're starting.
did David pass it? Do
Okay.
we want to take a look at David's
David,
code?
Richie, anyone you got an idea, or do we want to look at yours next?
Yeah. Yeah, I mean, the code,
What am I missing?
honestly, like I worked it 100 times. It looked good 100 times, and
Yeah.
it's still not passing all of it.
Figure out
I
what
don't
I'm
understand
missing.
why.
Mine is very similar to his, the way, except I just wrote it a little bit different, but still the same, like results.
Oh, wait, hold on.
It has something to do with that second loop.
Get rid of
Sure.
this.
Is it because
Also,
current
uh,
plus 1?
oh
Yeah.
yeah, get rid of that because you don't. It's
You don't
not
need that
0
anymore. Get rid of this. Yeah, that too. But I don't think that'll fix the problem. We don't need this line.
You don't need this line?
No.
Oh, yeah, because okay. Okay,
Because it's gonna, no matter what, it's gonna change the minimum.
right,
I
right.
still don't think that's the issue, but
I don't think
After
so
this,
either.
we'll-
I think it has.
Dave.
I think it has something to do with where it's starting and where.
Yeah.
But
Is it
you're
maybe-
rechecking the same numbers multiple
is it
times.
Kind of. But again,
Current?
we're only checking from the current number forward. So we're never looking back. So once we move forward one,
So
so
maybe 1.
what it's doing is it's going to compare. Go ahead and run it. Yeah. Stop
I
here
know.
for a second though. Stop here for a second. Let's go back up. It's going to start here and then go through all the numbers, and then it's going to move
Yeah.
over 1
And then repeat.
and then repeat
Yeah.
from
So
here
current-
forward.
so
So we'll never
current
we'll only
is
check
right.
this number once.
Right?
I
Current,
realize.
correct?
Yeah, never mind. Sorry.
So, current plus 1 is correct, right?
Yeah.
We
Yeah.
want to, because if this index is at 1, we want to start at 1 plus
Mhm.
index
Yep.
at
Yeah.
1.
Exactly.
That's right. So maybe are these index wrong? I don't understand. Like,
I'm
I
trying
don't
to figure out what I'm missing.
I built out a hash map with the second values were lists of where all the indexes were, and I could find where all the pairs were and all the triplets. Because some of these have triplets in them. Some of these have 3 numbers in them.
No, they should only have 2.
No,
It should
don't
never-
have
Listen,
3.
guys. To be honest with you, I don't like that if statement at the bottom. That number size, that doesn't make any sense to me. To be honest with
Take
you.
it easy, Alita.
Bye,
'Cause
Alita.
if it's
Bye,
equal to
Alita.
0 or less than 0, you should return 1.
It'll never be less than 0.
Okay, so then why are you doing absolute?
because if I go through the for loop, it goes all the way to the end. So then 4 minus 1 equals 3, and then it's gonna subtract 1 minus 4. So it's gonna give me a -3.
No. It should only subtract the bigger number.
Yeah, no, I guess I only took the
Yeah.
absolute because you had it. I just realized, yeah, next is always going to be larger than
It'd be
current.
bigger. Yeah.
And next is always
Yeah,
going
but
to be bigger.
that's wrong.
That's
And
not
Why?
that's wrong because you're supposed to be subtracting the bigger number. You're supposed to be subtracting the smaller number from the bigger number. So it should
No.
always be
Not
No.
guaranteed.
No, you don't have to. You can do about absolute.
no,
if it-
because if you're going through it forward, the first number, aka current, is always going to be smallest, right? So
Yeah.
You're gonna
that's
go back, subtract 0 from
Hmm.
5 when it gets from the
Oh, let's
beginning
try it,
number to the
no,
last.
no, no.
number.
You should be. I'm sorry, I'm mixing it up because
No,
I'm,
he is
I'm mixing-
subtracting next and
I'm
current.
mixing next and current.
Yeah,
It
switch
should
this
always
between
be.
Yeah.
current next.
It should always be the bigger number minus
Yeah.
the smaller number.
I do see that in the code now. It says J minus I, not I minus J.
Right.
Interesting.
So you should never get a negative number. The only time you should get a negative number is only because there's
Again,
no matches. And you're
I'm not sure
divorced.
about that. Because I do know, I will showcase that in the actual minimum distance example, they do use the absolute value symbols. Go to the,
Yeah,
the
yeah.
challenge.
You will
Go to
get
the
a
exercise.
because like hold on, like if I print right, so it's gonna iterate through the array 7, right? So then it's 0 minus 5, and then it keeps going all the way through. So then it's gonna be
Yeah,
5
hold on.
minus 0.
Yeah,
And then,
yeah, it should be 5 minus 0.
then it's gonna be index 1 minus index 4, right?
No, it should be 4 minus 1.
Right.
Hold on.
Well, I'm saying like the for loop is gonna minus it 4 minus 1 is gonna be 3, and then the for loop is gonna keep going, and it's also gonna minus 4.
But again, hold on. Before you say that the larger number is always going to be first, there's no guarantee in it. Go back to the example for 2 seconds. Here.
I know.
By
I
clicking
know
is
why
over.
it's wrong.
Scroll up. Okay, give us 2 seconds. I just want to make sure that we see what's going on. Scroll up to the top, please.
That's not something.
Yeah, scroll up to the top.
All the way. I want to make sure it's understandable that the absolute value is allowed. These symbols here, these 2 pipes, is absolute value of the result of the equation.
No, I understand that.
Yeah,
I
and he's
do.
yeah.
I'm just saying though, to be honest,
Hmm.
because I is always going to be the first number, right? Whether it be 1, 2, or
Yeah.
3. J is always going to be I plus 1,
Mhm.
right? And
Yeah.
the if math serves you correctly,
True.
J is always going to be a bigger number than I, so you
True.
should never have a negative number.
Which would mean that next should be the larger one. So it should be next. So what he had was right. Next minus current was correct. We just don't need the ABS.
Right. That's what I'm saying.
Okay.
I was just to speed up
Alright,
because it's
Yeah.
another calculation you don't need.
Yeah.
But the
Switch
thing
this
is,
back. Next minus current. You were right.
it should be
Switch
next
this back.
minus current. No, it's current minus next. He's right there. See, he's
What?
No,
What?
no,
No.
no.
Current
Oh my God,
smaller.
oh yeah,
Current
sorry.
smaller.
Next.
Oh my God, that's why sometimes I love I and J because it's just easy. I know where it's at. You know.
I don't like those, and a lot of people don't.
Hey, whatever. Hey, listen. All I'm saying is first make it work, and then you can rename everything whatever
Yes.
you want.
All right, and you don't need the math ABS anymore. Is what we're saying, because there's no way for it to be negative.
I think there is.
Get rid of that in a second.
No.
Well, current next is always going to be larger than current. There's no situation where next will ever be smaller than current,
Right.
because next is always current plus 1 or higher.
Yeah, but
You
it's
said
not
right here.
sorted. Is it sorted? Is it sorted? The array's not sorted.
We're not doing the numbers of the values we don't care about. We're caring about the indexes.
Oh, the index. Oh yeah,
Right.
yeah. Oh yeah.
Current and next.
No, I
Current-
knew that. That's why I did it. Like
Yeah.
that.
So I'm just saying, yeah, you don't need the ABS
I'm getting
anymore.
confused. I'm
So
like,
we're
hold
good
on.
there. That's fine. But now, Christian, you said you know what the problem is.
Yes. So
Go for
it
it.
literally, your solution from the beginning was right, Joel. Literally from the beginning. I just realized you're never checking if there's never a minimum distance. You're never returning -1
Why not? That's what
because
this is doing,
you're
right?
always gonna no, because he's always gonna have a minimum value.
Why?
Certain
He's only gonna
distance.
find only if he finds a pair.
Not, but look at if
How do I go to submissions and check my?
the reason
It'll come back as 0 because if it doesn't find any pairs, it should come back as 0.
it's gonna
Because it never
you're-
calculates anything.
so,
Hmm?
how do I word this?
Yeah.
That's let me think through how I can word this without
Using
it.
my original code from the very beginning.
Like I said, I don't like that if statement. That's just
Well, the reason that
Come on.
this, so you're checking it every single time, no matter what, if there's pairs, and you're going through each one, starting from current, starting from the next one. And then
Mhm.
if they match, you are changing min to the minimum value of the two.
Mhm.
Now,
The current smallest versus the new distance. If the difference is smaller, it'll take that. If the distance is not smaller, it'll keep the
oh,
original.
no,
min.
you are. Because
Yeah.
because
Yeah,
if
he
min
is.
is set to numbers.size.
Right.
Wow, okay. Never mind. I don't know why that's not
And
working.
just to clarify, David, this if statement, what it's doing is just saying that if we didn't find any pairs, return
Then it-
-1. That's what this
exactly.
is doing.
So
If
this
we
this-
found a pair, this
yeah.
is going to get changed.
No,
We're
this
just
makes
checking to
sense,
see if it's
David.
in the default value. Yeah.
This makes sense.
Okay, I mean,
Min never changes because if min only changes
It would never
if it's
change.
if
so
it's
this should
equal.
this should run right now. This should work.
Should. That's what's confusing me right now.
Yeah, that's what I didn't. Me
And
and
see, the reason why the one that I did exactly the same as you did with the for loops. The only thing is I was adding into the array and then figure out which one was the smallest by sorting it. If I had an array size of 0 where I didn't put any numbers in, then that's when I would pass the -1.
you want to show us your
Shouldn't need
code
that.
so we can
I just want to, yeah, let me take. I want to take a look at it because I'm just curious
All
now
right,
because
I'll stop
that
you.
shouldn't be necessary. For the meantime, Joel, can you just copy and paste, send me that code quick? Just want to look at it quick.
Yep.
Something's bugging me about it, and I'm not seeing it. I don't know why.
Me and Jim were coding till like almost 12 o'clock at night yesterday.
Yeah, Slack it to me if you want to do it. You can do direct message or in the group chat.
Like I said,
Okay,
I
I'm
broke
sorry.
I did a hash map version where I broke out where location of every index was, and when it had
Nice job,
multiple
Elaine.
ones, they would put it into a list, and I could see which ones were duplicates and which ones had more than because some of them have 3 of them. That's the thing. Is some have triplicates in it, but
Doesn't matter though. This will still go through. He doesn't stop
Yeah.
scanning for them. So
Mm-hmm.
funny thing is actually he could do a continue on the outside function if he finds one, but this should find it. This should see it.
Oh wait, did it pass everything? Wait, did I just pass everything?
No.
Oh no, I passed
No.
recursion. I was looking at recursion.
I don't know why his isn't. That's so weird.
Okay, so
Go ahead and share yours, David.
This is what it's like to work and like nobody have a solution to the problem.
So right here.
Stressful.
Right? So we did the same thing with the for loops. Here's my array list. Well, our array list. We got the values beforehand before I went into this loop. And this is where we do the comparison. So, right? And then we add to we count the occurrence, which it kind of sort of isn't necessary anymore. There's the j minus I.
Yep, that's what I had.
All right, I added to that array distances, and I actually printed out so I could see it. But here's what I do is I sort we sorted the array distances because then it's going to put the smallest value in the front, right? So if the size of this array, if I never added anything, obviously it's a -1. If I did, then all I have to do is return to 0 position because that's going to be the smallest. Now when I
That's
run
such a simple solution. Like I could have figured that out in 10 minutes.
I did something like that initially, but
Hold on.
but I couldn't get it to work right.
But when
As
we
much
run the
as it
cases-
works, I would say that again, this was my biggest problem for you is just this is a high memory usage method. That's my only biggest issue with this. Is that if
The
I had
collection
a,
dot
if,
sort.
what's that?
Is it the collection dot sort that's
Not even that. It's just we're storing so much data that is unnecessary in an extra array.
I
Unless-
totally get you, Cliff. But like I said, I solved the problem, and then
Yes, and that's good. I mean, I'm not saying that you're bad. That's already
no,
it's better than
I-
anything. Yeah.
no. I'm not saying any solution is better. I'm just saying how I approached it
Yeah.
because I took it step by step. I'm like, all right, well, what do I got to do? What do I got to do? How do I solve this? And then once I fix it, if I have time to go back, I'll refactor it. I mean, but that's all test cases pass that way. Because I
That's so
initially.
interesting.
So like you are doing the same thing. I don't know where you're going wrong. That's the thing.
Yeah. I'm not seeing what his isn't doing right now either.
Right. I can't see what it's doing because I'm trying to look at your logic. So show me your screen again.
Yeah, go back to it. I'm running some system.outs right now. So
Yeah. Go ahead, share your screen, Joel.
All right.
Because I want to
This
go
is
through your
bizarre.
code piece by piece.
All right, buddy.
I'm a
Let's.
little confused
rock
on
and
So
that
roll.
too.
go ahead and put it in on the testing window. I don't care about this window.
The debug.
I don't no, not the debug. Go in the hacker rank window.
Okay.
All right, so yeah, open that up. So do me a favor. After your first for loop, after that bracket right there, the one on the right, hit enter. Just do a whack whack. So like for comment,
Okay.
no, other way,
what the fuck?
What?
other direction. It's in the other direction, right?
Do a comment, in other words.
Yeah,
No, he's
comment.
right. That's
Oh,
slash.
okay.
Yeah,
Yeah.
yeah. This
That's
is
right.
Sorry, it's taking a while for it to show up. Okay, so after the next for loop on 27,
okay.
just do an enter and a whack whack. So that way I can separate the stuff out.
Kristen's losing it.
Whack, whack.
Sorry, I'm mad at you.
Before you do anything else, though, can you just do me a quick favor, Joel? Can you just submit it again? 'Cause I
That's
don't know which
why.
test
That's
cases
why.
you're failing.
You're not, the first one. Why are you doing a -1?
What? Because he doesn't want to touch the last number. He'll get an
Last
integer
number.
overflow on the second loop.
Did you not do a -1?
Look at my code.
Wait, if you never touched the last.
Stop. Don't do that. You're going to get an integer overflow. I can guarantee it.
Yeah, you
No,
are.
I
will
know.
get
I
an
know. I
integer
know. I
overflow.
am. But I
Okay.
mean, I
No, I didn't subtract.
What?
I didn't -1 from size.
Wait. You did, yeah. Why did
did
yours not just fail? Hold on.
It didn't fail. Oh, wait, what? What?
Same test
Alright.
cases, but I'm surprised it didn't fail.
All right, scroll back up.
Wait, how many items are allowed in the array? Are you using ints for your loop structure, David?
No.
I'm sorry. What? Say again.
Are you using integers for your looping structure?
Can you message me your code, David, and
I can show it to you again.
message to me?
Yeah, I'll message it to you if you want, but I'll show it to you right now. You have to stop sharing though.
Okay. Hey, did you see Doge hit 75 cents?
Over on
Yeah.
Saturday? Yo, that was insane.
That's crazy, right? I know.
Dipped.
I just want you guys to know I brought up Doge when it was 4 cents.
That was
heard-
when
Yep.
Richie also bought Doge.
I turned $500 into $8,000.
There you go.
Yeah.
All right, so see my code. We didn't. Me and Richie didn't subtract 1 from either one for the test. For loops.
That's so. Oh, because it's gonna stop either way.
Right.
So when it reaches the length.
So you don't need to put the negative.
know.
You don't need to subtract from size.
Oh, right.
But then-
I guess you don't necessarily need to because then J is going to be less than size. The J will invalidate. Okay, I see why it doesn't matter. It's not going to make any change to Joel's code. It doesn't do anything to get rid of that -1. That's not
Yeah.
what's causing the break. Because yeah, you're right. It works only because what happens is that when J is equal to I plus 1, J is then greater is actually equal to size. So the second for loop doesn't run.
Right.
That's why your code doesn't break. Okay, that's why the -1 isn't needed on the first for loop, but yeah, it doesn't do anything. That's not going to fix Joel's code. What is it not detecting? So what's
I have
interesting is I
no
looked at
idea.
one. What is the edge case I'm missing?
If it has pairs, it should have the minimum distance, which it does. And then if there's no pairs, it's the same as the length, and then it should return -1.
I took
His
test
code
case
should work.
5, and with Joel's
could it-
code, I'm getting an output
Could
of
it possibly
18.
be something wrong with HackerRank?
It's unlikely, but
I don't know, because.
Well, you know what you could do in case if you're worried about what's in the buffers, you can reload you can do the thing where at the top right corner where you actually start typing the code, it'll let you clear everything out.
And you just recopy and paste it.
Right.
I went about it a very different way than all you guys did, which is funny, but
No, well, more than one way to skin a cat.
definitely
Homie.
work.
yep, that's fun about this stuff.
Yeah, that's what I'm saying, but yours should work.
Let me. You want to share your
Did it in
code?
SQL, I stored everything.
It's
into a
totally different
database
than what you guys are doing. It would
Totally
wouldn't help figure out your code at all. And I want to figure out your code.
Thanks, bro.
Figure it
I
out.
don't
Put it back up on the
understand.
screen, Joel. Do it. Do it now.
I didn't quite do it correctly, but Alito and I
Let's
got
terminate the code.
working.
Get to the chopper.
Get through the chopper. You
Joe,
baby, what-
share your code.
Hold on, buddy. I don't know why the Zoom controls on my computer are hard to find.
Zoom hates you
That is weird.
because you're investing in Dogecoin.
Hey, your boys
I should have
getting
jumped in
crypto
at the
rich.
25 cents, man.
I'm investing in a meme coin.
Everyone download Pi Currency and B. They're both going to be the next
Doge.
cryptocurrencies in about a year.
Which one?
Facts. They're almost in their final phase.
Nah, Elon Musk is setting Dogecoin up because he's gonna make the government pay for the SpaceX with Dogecoin. He's not gonna accept the dollar bills.
I think they dropped a hint that Tesla might start accepting Doge. I think that's what I was reading.
Oh, it already is.
Oh, it already is? Is it?
I believe so.
Oh well, that'd be
that's Bitcoin before, wasn't it?
So Joe.
Yeah, I'm looking for these controls, buddy.
Joe's gonna buy a new Tesla with his money.
Hey, listen, I'm preparing you for later on in life when your son is doing this. Dad.
He probably already does that.
No, my son actually doesn't call me dad. He calls me Joel.
What?
Yeah,
young.
Yeah, he calls his mom's name is Bella, and he calls me Joel, and we're Bella and Joel.
Funny.
That is interesting.
Yeah,
I can't wait to have my kids when they call me by my first name. I'm to look at them weird and drop kick them. What's wrong with you?
Well, my wife decides to actually give our first male my name. We keep the Cliff Chonier thing going and make the fifth. Then it would be dumb for him to call me by my name because then he's just calling me himself.
Calling him, yeah, Cliff. Yeah, that would be funny.
Yeah, call my dad Cliff.
Well, if you have a kid, Cliff, I'm calling him Cliffy.
I'm already Cliffy. You don't even understand that.
No, once you have a spawn, you lose the Cliffy. It goes on to the next one. You lose that, you become the old man.
Tell that to my dad, who still tries to take Cliff as his name. It's like, no, you should be Clifton now. The second died. You should now take on the mantle of Clifton.
Right.
And I should be able to be Cliff now. It's like a Highlander. You move up the chain as the previous one expires.
Right.
Well, my son's name is nothing. My son's name is Caleb.
Yeah.
So nothing.
He can get away with it.
Yeah, exactly.
It's when you start getting to us, like we're the third or the fourth.
Oh,
or fifth,
wait.
that's when you start getting into trouble.
What am I missing here?
Oh, right. I'm writing it out.
Oh, this is my solution to the problem that we did. Similar to what we did today. This took me 20 minutes to write, and then this has taken me hours. It's so weird.
Curious on something.
That is so bizarre.
Yeah, David, I'm gonna ask you a small favor, just sending me your code, because I don't know what I'm missing in Joel's. I'm gonna have to
You
just
have it.
rewrite it.
You
I have
it.
yours? You sent
Yeah,
it?
yeah, because you're in the you're in that chat.
Oh, there it is. I didn't, wait, where? Oh, right, you did post it there, didn't you? I forgot that you posted it there.
Yeah.
I forgot that you posted it there.
That's what.
I
That's
saw
what
like,
you're like. You didn't post anything. I'm like, what are you talking about, Cliff?
I don't care about the warm-up. The warm-up wasn't necessary to post.
Yeah.
I was looking for the assignment, for the time challenge. The warm-up is for your guys' benefit, but I'm surprised why, yeah, I'm not seeing what's wrong with Joel's code, which is bugging the shit out of me.
Yeah,
I can't see it either. Like I said,
Why?
I just like to make it work first, and then I figure out like if I want to make it fancy, you know.
Joel, can you hover over your double equals? Why is it lit up? Go up, right? Hover over it.
With dot equals?
That doesn't make sense.
No.
No.
That doesn't make sense. Why would it?
Address comparison versus like. We don't want to do
It's
like if they're both.
It should be double equals, but why is it telling you to do it with?
Maybe because it's in the list.
No.
No. You know what the problem? No, that's .get. So you are getting the values.
Yep.
The hell.
What is it?
I thought you were
right.
comparing indexes,
He
but
needs another parentheses at the end of there to fix it.
Yeah. No, that's I just
No,
don't
but
understand
no. I see what Christian is saying. Christian is saying why is
number objects. Why is it taking a number? Yeah, but that doesn't make any sense.
Yeah, and it says compare using equals, not equals.
No, that's right.
Yeah, so that's right. Yeah, this is right.
Mhm.
But then why?
I forgot how to run. I forgot how to run these cases, man.
So why is it lighting that up? I don't get it.
Well, let's
No, it's not gonna work. I just don't understand why it's letting that up if it's telling you you're right. What doesn't make any sense. That's why some of the things in IntelliJ just don't make any sense why they light them up.
Yeah.
You know, this sounds stupid, but do me a favor.
Go
in
for
the
it.
first for loop,
I like where this is going.
in your line 96,
You know what he's gonna
line
say.
96, right? Hit enter at the end. All right. Do just whatever variable. Just name like the first variable. I don't know. Whatever you want. Name a variable there.
What type of variable?
Int. But
We're storing the number by doing the get once.
yep. So equals.
Oh my
to,
gosh. Oh no, that's not it. Sorry. I'm gonna mute myself.
Equals to numbers.get current. All right, so there's that. So replace that with EX in the for loop. Oh, yeah, right there in the if. All right, and then at the second for, do the same thing at line number 98.
And then do
int XE. Int XE, the reverse. Who cares?
I just do what this is how Jim likes to write index. All right, Jim?
What?
Yeah, but we're not storing index, we're storing the value. So
Yeah.
Yeah, but I'm just so we know that it's the value.
yeah, that's fine. So whatever.
Wait, why is that working? Wait, are you comparing that I think is gonna fix it. I just tested it myself and it seemed to fix everything on mine.
Well, because
is it comparing the memory addresses?
I think that's what's happening is it's comparing the memory addresses,
kidding
not
me.
the not the actual numbers.
So is
So-
what Christian said actually hinting at something? Was comparing the objects and not the methods and not the actual values?
See, but
That doesn't make
that's what
sense.
it, I've
See,
never seen
and
that
you know,
happen
like I
before.
totally understand where people say, "Hey, you know, you're wasting line of code," but hey, if I put it into an int, I know
Yeah.
it's an int. You know what I mean?
Yeah.
So
No.
now,
I
now
get it.
test that out and let's see if that runs.
That'll work because I just tested it myself.
Don't you take my glory, Cliff.
I'm not. I'm telling you
I'm
that
just
saying
kidding.
you're right. I'm saying
I'm
I'm
just
expecting this to work. I'm expecting you to be right.
Sorry.
I'm
No,
giving
that
you
works.
props already.
This works good.
Scroll
All right,
down. You'll have numbers. Hold on. Scroll down.
Oh, sorry, I just submitted it.
It's fine.
Oh
goes.
my god.
What the
Oh.
hell?
Crazy.
I'm a monster.
Inline
That is
coding,
bull.
inline coding doesn't work. I
I'm
don't
just
understand why inline coding don't work.
Well, because
That is crap.
So
listen,
one, I know one is address comparison and one is content comparison. Yeah, so look, address comparison, content, great. So this is content.
Oof.
This is
This
all
is something I will say that on one hand, this is a really good lesson to be aware of and be careful of during the interview tests.
yeah,
yeah.
So
yeah. So see, the dot equals, he was right about the content, but like you should be able to do an equals to.
you really
to-
should with that. I'm surprised you can't. That baffles my mind. I never would have found that myself.
Well-
I've never ran into that. So good
First
catch on
and-
that, David.
first and-
Trying
Well,
that
you
out.
gotta remember also, this is Java 8. This is Java 8. Sometimes, like when they upgrade to 15, they fix things like this. So, you know, this.
So
might
here's
not
the good
be
thing. So
back
the main,
then.
I do want to clarify, we do not need the array. So I was right on that. Yeah. You just need the minimum number. You just want to store the current min. You don't need to store all that history.
So,
But interesting
Wait,
that's
wait,
the thing.
did-
Wow,
Wait, David, you didn't do equals?
he did.
I
like
did,
this.
but I did it just like that. We made
Except
a very
for one. He did a single index and then a single get. So he did line 97 and then his line 100, the IDX, he did numbers.get next.
yeah.
So he compared his EX against the dot get. So he had a single dot get instead
Right.
of both being dot gets.
so line
That's what your
104
difference was. Your
So here
compared
we
to
were-
two dot gets.
So when we get it from the array, we're just comparing the address the address and
Something. I don't know what it was comparing exactly, but it wasn't comparing right. But apparently you needed one. It's to me, it seems similar to the concept of like integer division. As long as one of them is as long as one of the two numbers is a float, the whole thing is a float. But if both are integers, it's integer division. It seems in this that as long as one of the two items is an actual int, it's fine. But if they're both methods, it does something else. And I don't know what it did.
so equals checks if both objects point to the same memory location,
Huh.
whereas dot equal
Guarantees an evaluation of the
okay,
object.
evaluation,
Interesting.
the comparison of values.
Yeah, it's weird. That's why, like, hey, I do everything simple first. I know it's a
Yep.
pain in the ass, but you know, and it sucks for me sometimes because it makes me take longer
Mhm.
on the interview exams.
Yeah.
But hey, if whether I solved it in 5 minutes or I solved it in 44 minutes, I still solved it. So
As long as you solve it within the time frame of the interview, I don't care.
right,
If you have to make
right,
sure you
exactly.
solve it within the time frame of the interview.
No, well
So-
That's
this
key.
but this is Joel, like this right here. That's another good way of troubleshooting too. Is like if you're doing comparisons like that with
Yeah.
methods,
Get rid of
it's-
your inlines. Yeah.
right?
Try that just for the hell of it. The main thing about debugging is just constantly just changing something to see what it does. Bring it down to its most simplest basic form.
So
Yeah.
this turned it into an int, and now we're just comparing if the int
We're comparing two ints instead of
Instead of
two methods, I guess.
to address.
Method
Right.
addresses, I'm guessing. Yeah. I'm
Yeah.
guessing that's what it was doing. I'm not exactly sure what it was doing, but it seemed like, wait, no, you're right. It was doing object comparison. The dot gets were returning integers, not ints. The dot gets are returning objects, int and int. So it was comparing memory
So
addresses.
it was yeah.
But
Okay.
with Davis, he was comparing an int versus an integer. So because one of them was an int, it was doing the value condition. So since both the yours were both integers, both objects, complex objects, it was
but
doing a
then
memory address.
if that's
That is
the
a no-
case, right? If that's the case and we solved it, why was it that some of our test cases were passing?
Yeah, why was that?
That doesn't make
That part I don't know. Unless the ones that you were passing were the ones that were -1s and had no matches.
No, we
well,
had
you
ones
gotta
that were
think
like
about
3
it.
was passing.
we had a couple that like I think it was like
Yeah,
Yeah, definitely
we
something to
had
look
3
into,
that were
but
passing.
definitely to look into why the other ones were passing, but they were probably false positives. Just luck of the draw, possibly, for all we know.
The other question I have is, what exactly is line 190 doing? I kind
190?
of understand it, but don't completely understand it on his code in IntelliJ.
I don't think he has a line 190.
I'm sorry, 104.
I was like 190. I was like,
I'm
where's
sorry.
104?
It looks like a 9. Yeah,
So
104.
math.min just compares two numbers and takes the smallest number out of the two.
Yeah. So
Okay. All right.
Yeah, so and then we're comparing our previous value of min to our new difference of the array.
To see which one, just keeping whichever one's smaller.
Oh,
We just want
right.
the smallest
Okay.
version. Yep.
And then if you want to complicate things more, you can always do a math.min as well. And then you can compare 3 different values. So you can add another one.
Oh, okay.
Put in like 5. I mean, you can put in whatever value you want, and then it'll take the min of this, and then they'll compare it to this one. So it's
But
like
that is interesting. Yeah, I didn't even think of it because I just noticed this little bugger right there. That was your issue. So the dot gets returning integers. So you're doing integer equal integer comparison, which are both objects. That's why your issue. That's why you were getting memory addresses. Whereas since David had at least one of them extracted into an int, he was doing an int compared against an integer, which was guaranteeing value expression. I'm not sure exactly why. Excuse me. The other ones were working, most likely just false positives. I can't tell. We'd have to do some testing why you were getting some false positives. But that is an interesting thing to be aware of. Doing an integer equal integer does not work, right?
Yeah.
In all situations, apparently. Fascinating. But yeah, this was good learning. This is a good learning experience. Good
It could
stuff.
have been false positives due to Jim's idea of finding that there's triplets. It could have been matching like a different.
But even then, wouldn't it be address comparison true? Even if there was triplets.
Without doing more testing, I'm not sure. But I don't know exactly what it was doing. That is weird.
I'm kind of curious because, like you said, you passed a couple test cases. So
yep, it'll be curious to find out why.
Figure out why, yeah.
Yeah,
I mean,
would be interesting.
Do you want to see which test cases we passed?
Well, I can let you guys go to it. I actually got some other stuff I gotta get going to work on.
I gotta
reviewing some of your code.
No problem.
All right, guys.
These things are good. You guys are learning with this stuff. This stuff's great to get into. So excited about it. It's good to know these items for the interview tests. I'm gonna try to get this video up so everyone can enjoy it.
All right. Have a good day, everybody.
Hey, now you got something you
Thursday.
can trip everybody else on, Cliff.
Seriously. That was cool.
There it goes.
All right.
Take it easy.
Night.
All right.